every single one of these problems is always going to fall back to this generic rule. So, arithmetic sequences, arithmetic series. We're probably only going to work with sequences today because we haven't gotten any further than that yet so far, so I doubt we'll do that in this class. What does arithmetic sequence mean? Do you know?
We learned it in 8th grade.
Okay, what is it?
Something where it has n to the nth term is that number.
Narrow that down somewhat, because there's two things that have n to nth terms, because arithmetic and geometric, they both use nth terms. What is the difference between an arithmetic sequence versus geometric, if you've heard that term?
All I remember is your student teacher taught it to us before she got bullied.
Okay. There's a comma? All right. Hey guys. Yeah. Now, the difference between an arithmetic or a geometric sequence, numbers in a sequence have a common difference. A geometric sequence have a common ratio. You're multiplying by something. In an arithmetic sequence, you're either adding or subtracting the same number each time to each consecutive number in a sequence. Okay? For example, if I just say 1, 3, 5, 7, what am I doing to each one of those numbers? I'm adding 2. So an arithmetic sequence is a sequence with a common difference. Now, when I'm saying this common difference, that doesn't mean it has to be subtraction. It could be adding and it could be subtracting, as long as it's the same amount each and every time. And what's nice about these arithmetic sequences, they all have the same basic generic equation. They all have this thing called the nth term. The nth term is written out like this: a sub n. That value n stands for some number within the sequence, whether it's the 3rd, the 50th, the 816th term. That n value means the same. It's some number in the sequence, follows this rule. It always follows it by the first term within the sequence plus whatever that number is minus 1 times the common difference. And we reuse that equation in every single example throughout today and probably most of tomorrow. This equation, it kind of looks familiar. I think you've seen this before. Now, if you look at that, do you guys all agree that there's basically 4 variables, if you will? All right, the a sub n and that other n, they do relate to one another. That n value will be the same. But for lack of better terms, if I gave you 2 of those variables, you could solve for the 3rd. And that's what's going to happen a lot. So we're going to use this nth rule for first term plus n minus 1 times the difference to solve a bunch of different problems. But it all falls back to one generic rule, which you guys like to follow. So take a look at this. If I'm looking at these 2 sequences, and let's just look at them before, don't even bother writing them down. If I'm looking at this and I have -3, 1, 5, 9, and 13, is that arithmetic?
Yes.
Okay, it's going up by how much each time? 4. It's going up by 4, okay?
But it's going, if difference is subtraction, right?
It can be, but in this case, remember, this common difference, it can either be going up or down. As long as it's constant, it's the same value, it's always going to be, it's changing by 4.
Okay.
All right, in this case, it's just changing by +4.
Okay.
All right? So here, I would say, yes, this is an arithmetic sequence. What's the first term? -3. So if I wanted to write this out, I know my first term is -3. I know that my common difference was how much?
4.
It goes up by 4 each time, so the difference is +4. And if I want to write out this nth rule, I know everything that I need to know. I start with my generic equation, my rule, my first term, plus the n minus 1 times the difference. All I do is substitute in and combine my terms. Okay? I know my nth term will be my first term plus, I don't know what n is, but I subtract 1 from it and multiply it by 4. Distribute out the 4. What's negative 4 minus 4? Negative 7, very good. So I write out my rule for this sequence. My nth term is nothing more than 4n minus 7. It's kind of customary to put your number with the variable first and then tack on. Think of it as a slope-intercept form, if you will. It kind of looks like that, mx plus b. All right. Sometimes people, if that n value can be negative, which it does happen. Sometimes people put that, like 7 minus 2n, and that's fine. It's not a big deal. Okay. But that's what we're doing today. We're writing equations of sequences that are always arithmetic. Not this mumbo jumbo of 5, 6, 7, 6, 7, 8, 8 ninths, 10, 9 tenths, 11, whatever.
10, 11.
Yeah, you know what I mean. We're not trying to figure out that because those weren't arithmetic. We couldn't come up with a basic formula that always works. If it's arithmetic, this formula always works. If it's a right triangle, what always works? Okay. What do you got?
Oh, so this might be a stupid question, but will we ever be solving for n? Or is
Yes.
n-
We're just starting out. It gets harder.
Oh, dang it.
That's-
Sure.
I was gonna say, could you potentially say like, the h to the n is like, say you want the 12th term?
Yes.
N be 12? then?
Yes, sir.
Okay.
If I wanted to find, exactly, this is a great question because we're going to do that one here in a second. If I wanted to find out what the 12th term in this sequence would be, that means my n value is 12. So what's 4 times 12 minus 7?
41.
Done.
Okay.
Make sense?
Yes.
Okay. What about that second sequence? 2, 5, 10, 17, 26. It's not arithmetic, so what do? You leave it, nothing. You say no.
Oh, no.
Because it doesn't.
Yeah, you can figure it out because it just doesn't fall into the terms of an arithmetic sequence to write out the rule. It's still a sequence, yes.
Never mind.
Yes, ma'am.
Where'd you get 12 from?
Mr. Ward just made it up. He said, what happened? He asked the question, will we be finding like the 12th term in that sequence? And he asked, would that be a sub 12? And I said, yes, and that's what it's going to look like. So if we wanted to figure out what the 12th term was, instead of counting out, adding 4 each time and listing it out, we just substitute into the nth rule, and it gives us the nth term.
Okay.
Does that make sense?
Yeah.
He's kind of ahead of me by a couple of minutes. It's okay. All right.
No, it's not okay.
This is so much
It is so much easier than yesterday. And yesterday was supposed to annoy you.
So then
It
basically,
did.
if we were to substitute in for them, it would give us -3.
What would be the negative term?
Like substituting in the a n as a1. Like
Yes, if you use 1 for n, yes. Yes, ma'am.
Why was the second one already?
Oh, do you see how it's not a common difference each time? It goes up by 3, 5, 7, 9. It's not going up the exact, each one of these has to have the same spacing. And like you guys figured out, you could get the next term because there is a pattern involved, but it's not an arithmetic pattern. Okay, that's the difference here. So, if I'm looking at this one, I have the sequence, and this is exactly the same thing you were talking about, Mr. Ward. We're going to write out the nth rule and then figure out what the 20th term is in the sequence. So we're going to do exactly what we just did. We know that this is an arithmetic sequence because it's telling us it is somewhere. And it starts at 50, 44, 38, 32.
Subtract 6.
It subtracts 6. So we start out, and I'm going to do this with each and every one of these problems, and I hope that you do the same thing because it will help you to remember these. Write out the generic formula. The nth rule is first term plus n minus 1 times your difference. What? Deep breath. It's okay. What's your first term? 50. What's the difference? Good, so your first term is 50, your difference is -6. Substitute in. A sub n is 50 plus n minus 1 times -6. What are you going to screw up? Very good. You're going to distribute the negative incorrectly. Just be careful with that. See it every day, all the time. Whenever there's a distributed property with a negative symbol, most people screw it up. Don't do that. It's simply stated, right? Just don't do it. So you get 50 minus 6n plus 6. If you wrote it as 56 minus 6n, perfectly fine. Absolutely nothing wrong with that. There's my nth rule. And now, just to figure out what the 20th term is, what do I do at the end? We're not doing electrical work. We're not plugging anything in. Substitute. Do you have a fan to plug in? A light? I could use another fan. It's getting warm in here.
I'm barely keeping warm in this jacket on.
Bring a Snuggie.
Wait.
Wait. Let us.
No, it's a trip hazard.
You should become Mr. Crunch and like do stacks of everything.
Yeah. In this case here, in order to figure out what the 20th term is, now it's just, well, negative 120 plus 56, and you get? Negative 64. Yes, Ann?
If we know we're going to be looking for the base of the sub 20th place, could we from the beginning, instead of finding the arithmetic sequence, just plug it in along with the rest and go ahead through it?
Oh, just to try and continue to write it out?
Yeah.
That's annoying.
Wait, what? Like, instead of doing the a sub n equals 50 plus n minus 1 times -6, instead of doing that and finding that first, couldn't we just do the 20 minus 1 times -6 and then go from there and do like a couple less steps?
Oh, I see what you're saying. You still have to, but you're saying just to go right from here?
Yeah, and plug it in.
Okay, the only thing is, that's fine if it just asks you to find the 20th term, but here it says write the rule first.
Okay.
So in this case, it's asking you to do both parts. I see what you're saying by shortcutting a little bit. That's perfectly fine if you need just to find what's the 20th term. But if it asks you to write the rule and then do both. Okay? It's a fair question. All right. It's scary when you guys pick up on things after a while. So let's make it difficult.
Oh, great. Here we go.
Oh, it's just getting started.
That's nonsense.
It's not necessarily the fifth day of gas, started getting upset.
Write a rule at the end term.
So if I'm going to write a rule for the nth term, I know that the 13th term in this sequence is 30. And I know the common difference is 3 halves. Okay? So, again, I'm going to start by just writing out my generic equation. My generic equation is the a sub n is first term plus the n minus 1 times my difference. In this scenario, the value of n is equal to how much? 13. Excellent. So my n value is 13. Therefore, the 13th term is 30. I also know that my difference is 3 halves. Which one of those 4 variables then am I solving for? Yeah, I'm solving for the first term. Everybody see that? You got it now? So we're going to solve this for my first term. So we substitute in what we know. I know that the 30th term is the first term plus 13 minus 1 times 3 over 2. What's 13 minus 1? What's half of 12? Multiply it by 3. So what's 3 halves of 12? 18?
It's where it is, you're gonna do it. We're showing them
It was given.
3 halves
The 13th term is
Oh,
30.
okay.
What's half of 20? What's 10 times 3? What's 3 halves of 20? What's half of 22? What's 11 times 3? What's 3 halves of 22? You guys are all going, wait a second, that actually works.
Yeah, it does.
It does. Math is actually working for once.
I like that because you always have that one whenever I can do that.
What's my first term in this case then, ladies and gentlemen?
Wow.
So now I know my first term is 12. Am I done? I gotta go back and rewrite that into the original formula. The original formula was the a sub n. So, the nth term is my first term plus the n minus 1 times my difference. Well, that's 12 plus n minus 1 times 3 halves. Distribute the 3 halves. Everybody agree on that? So you had $12 and you spent $1.50. How much you left with?
10.50.
So your answer is 3 halves n plus a 10.50.
I have to write it out before I do.
I distribute up 3 halves. You guys not used to skipping steps?
No. Miss Lo would have drilled it into our brains so hard that you have to include like how you type the keys on your calculator.
Yeah, like
Yeah.
just to show every single
No,
step.
don't have to do that.
And that's like that's just stuck with me.
I mean, I thought it was
Yeah, you really can't do that. Not only I would throw something at you first of all, but then secondly, you know,
it was Chucky, Danielle, and Steven all sat in a line. We got both of this. We all got it.
all I did there, guys, was I distributed by like terms and I did it rather quickly.
Why is
Is it the end of the world?
Why is the
Yeah.
12 gone?
What's up?
Why is the 12 gone?
What do you mean the 12 gone? What's 12 minus 3 halves? What is 3 halves? 3 halves is $1.50, right?
Yeah.
Okay, $12 subtract $1.50, you're left with
I get it. Less money.
10.50.
less money.
You see,
That's
Not enough for
see, I'm not gonna lie.
Genius.
No, there's more. This is just getting started.
There's more?
We haven't even got to the difficult stuff yet.
Oh well. That normally means the end of class. I'm not even joking. That's I would start my brother before class, but that's hard.
Do this one.
3 halves and
Write out the rule.
plus 1. Okay.
I want the nth rule for this one. Following the same basic pattern on this one. You've got your common difference and you know your fifth term. I'd like you to write out the rule for the nth term in this case. Tonight, I will talk slowly.
Just run the answer.
Okay? I know that my fifth term is 20. So a sub 5 is 20. It's going to equal the first term plus 20 minus 1 times a half. Okay?
Yeah, 5.
Oh, yep, sorry. It's 5.
What should be 5?
This.
How is that 5?
Because the end value, sorry, the end value is 5.
Oh.
The end value is 5, sorry. I didn't do that in any other class today. I saved the screw up to the end of the exam. So what's half of 4?
4. 2.
What's your first term? Okay, go again on that. Half of 4 is 2. My first term is 18. Therefore, I substitute back in. My nth rule is 18 plus n minus 1 times, what is it, a half?
Half.
Okay. Is it okay to write it as 1/2 n plus
I thought we were-
Plus, 17.5.
17 and a half? Is that fine?
17.
17.5, I understand now. Okay.
It's not 17/2, just so you know.
Yeah, I don't know why I said that.
Yeah, or there'll be times that I don't want to use decimals. When it's tabsies, quarters, I don't care.
Last year, Mr. Seth was like, fractions.
I know. I'm with them on that. There will be times that it will, it's very rare that I say it's okay. This is one that's not the end of the world. You'll see when it drop the hammer from the fractions. I'm just writing an equation. Yeah, so writing the rule for the sequence. And that sequence has this rule to it. This sequence that has the difference in the fifth term of 20 has that as its rule.
So AN equals 1/2 plus 17.5?
Yep.
All right.
So,
Got it.
this is where it gets interesting. There's two parts to this. We'll come to the second part here in a second, so don't worry about it. In this case, I'm going to give you two different terms within the sequence. One of the terms in the sequence is the sixth term, and it's equal to 10. The other term is the 21st term, and it's equal to 55. I'm going to write out the nth rule for this. Now, do you guys agree that you're given two sets of information?
Yes.
All right. Here's what I would do when I have two sets of information. I'm going to write it out twice. I'm going to write it out twice. Now, when I'm working with the sixth term, what's my value of n? So my sixth term is 10. So n is equal to 6. Good. When I'm working, oh, I wanted to use that in black, sorry.
Wait a second. Oh, never mind.
I just rewrote it. I wanted it because I'm doing it as two separate parts to start
Okay,
with.
okay. I thought you were just doubling up.
Okay? So can I substitute in those values?
Yes.
Okay? So 10 equals the first term plus 6 minus 1 times d. What's 6 minus 1? Okay. So I'm going to write it and leave it. 10 is first term plus 5 d. I'm going to do the same thing with the other set. See what I'm setting myself up to do here?
A system of equations.
System of equations.
Oh my god.
That one was what, the 21st?
Yeah.
So my 21st term
I should know what that
is
meant.
55.
No, I thought it was long.
So n is also equal to 21 in this case. Set it up the same, yes ma'am?
Oh, I was just thinking, couldn't you figure out what, the difference is by just like adding those and then dividing them?
You can do some of it like that, that's fine. That works for ones that work out real clean, but this is the generic way of doing it no matter what, even if they're nasty. Because sometimes you'll have fraction. That's why I always show the generic. But you're right, there are shortcuts. Okay. Again, I'm going to set this up with what I know. 55 is the first term plus 21 minus 1 times d. What's 21 minus 1? Do I have two equations with two variables?
Yes.
All right. When I set these things up, one of them is going to be easier to work with than the other. Could I do this?
Yes, you
Yep,
can't. It's
yep.
elimination.
Wait.
That's right.
Eliminate. I can eliminate that. Notice how I've got the same coefficient, same sign with the a sub 1, that first term. They both have a coefficient of 1. They're both positive. If I subtract them from one another, doesn't it go away?
Yeah.
I'm using elimination here, guys. It's just an equal sign. What's 55 minus 10?
45.
A1 is gone.
3 equals D.
What's D?
3.
3.
Alright, that's fine.
So your common difference is 3. Everybody see that?
Yep.
How do you find your first term then?
You plug in
D for an equation.
Substitute D back in here. So what's 5 times D?
15.
15 plus what is 10?
Negative
5.
So now I know my first term and I know my common difference.
So
Can
now
I
you
put that
can
all back
do
together in that
both
generic
and-
equation? Yes,
and
ma'am.
here.
Okay, so do you have to use system equations? Could you just do like 21 minus 6 and then 5 minus 10?
It works really clean when numbers are clean, but if it's nasty, it doesn't work as clean.
Okay.
Like I was saying, there are shortcuts to these. This will always work. All right, it's like using Pythagorean theorem. You can always fall back on Pythagoras if you forgot your triples, right? Same idea. Okay. So I'm almost done. A sub n is my first term. N minus 1 times d, and I just substitute in negative 5 plus n minus 1 times 3. All right. What's 3 times negative 1?
Negative 3.
What's negative 5 minus 3?
Negative 8.
There's your rule.
Okay.
That's part A.
Now we're on to part B.
Could we just stop for a stall, write down the numbers for a second?
Yes.
How many problems of these are not homework? This is like a huge amount of steps.
Part B was, what is n?
Negative 5 is first. Yeah.
Negative 5 was the first term. Well, we found d. We substitute d back here. So 10 plus a sub 1 plus, 10 is a sub 1 plus 15. 15 plus what is 10? Negative 5. We talked it. We didn't write it out.
So this, when you do that, you just subtract, right? Is there ever going to be a case where where smaller numbers on top?
You just move them. Move them around.
Wait, you just flop it if it's that?
Yeah. All right. Now the second part of this was very simple. What does n equal when a sub n equals 40? Solve for n when a sub n is 40. What do you do?
You don't plug it in.
Substitute
Substitute
solve
n.
40 in for n.
Not 40 for n, it's 40 for a sub n. Bless you. What's n?
Where did you get
That's the rule when you substitute.
16.
Yeah, it is. It's at the top of my head.
How do you move it down here? The 16th term in that sequence is 40, is what that basically is telling me.
I'm excited. I understand this so much more than yesterday's work.
Good. Yes, ma'am. It was part B of the problem. It was all the way to the top. You didn't see it. That's all. I just said, and these questions are going to give you the two numbers, and they're going to say, how many of these numbers would be equal to 40? That's all. What number in the sequence equals 40? The 16th term in the sequence is 40. That's all.
I assume you were considering how did you get negative 5 in your first year?
I did this again. I solved for it. What's 10 minus 15? Okay? That's where we're going today. Tomorrow we'll get into the more of the serious stuff. Yeah. Because tomorrow, you got a factor.
I did that really
I like that.
I could never get
Dang it, I got the wrong pair.
I did, it was bad last year.
last year I'd say I got more B's than A's.
Wait, I like those numbers. I don't even like them.
I didn't really get really during two bomb tests. Like
All right.
was really good too.
We'll go through those for tomorrow. After that, we'll start doing the second part of this setup. Second part of these style problems deal with the series. And when you're working with the series, there are going to be systems, or not systems, some factoring thrown in there. So, you gotta remember how to factor a little bit, Carl. I will show you a couple of tricks for factoring, some of which include using your calculator, so make sure you have it.